to learn about chemical equilibrium and about how to calculate an equilibrium constant. Besides, we will learn the Rice method to determine concentration. Let us start beginning. Life is all about balance. You want to have a balance in your bank account, balance in your diet, balance in your work and play. Think about what can mess it up. In science, we call balance as an equilibrium. What is equilibrium exactly? Chemical equilibrium occurs when a reaction and its reverse reaction proceed at the same rate. Look at this reaction. It's a famous reaction named Haber process. You can get ammonia by the reaction of nitrogen and hydrogen, and after a while ammonia can decompose to reform nitrogen and hydrogen. As you can see, the concentration of the hydrogen and nitrogen decreasing and the concentration of ammonia increasing. At a time when the equilibrium achieved, the all concentration are constant. As a system approaches equilibrium, both the forward and reverse reaction are occurring. At equilibrium, the forward and reverse reaction are proceeding at the same rate, as you can see in the reaction of N2O4 to establish 2NO2, and also in the reverse reaction. Chemical equilibrium is dynamic. It means that it's a constant motion. Once equilibrium is achieved, the amount of each reactant and product remain constant. This also can be explained as a rates. Rates going to be constant at equilibrium achieved. How we show the equilibrium? Just by a double arrow. The equilibrium constant. How we calculate the equilibrium constant? Here we have the reaction. We have a forward reaction and we have a reverse reaction. Rate of the forward reaction is a K, or a rate constant, times molarity or concentration of the reactant, and in the other side a reverse reaction rate is K, or rate constant times molarity of the product to the coefficient of the product, which is 2 here, the power of the coefficient. And when the equilibrium happens, these two are equal, and we can write it as a K equilibrium, which is the product raised to its power divided by the reactant raised to its power. In general, we can write it like this. A plus B gives C plus D. It's common in all reactions, so for writing the equilibrium constant, you can write it as a Kc, or concentration of the equilibrium is equal to a product in the power of the coefficient divided by the reactant in the power of the coefficient. So it's easy to write without knowing the mechanism. As an example, when the final ratio of each reactant and product reach a constant, no matter what the initial concentration of each of the product and reactant are. After a while, you will get a constant rate. Just give me an example. Maybe you ask me. Here we have nitrogen plus hydrogen to give ammonia, as we have before. It's a Haber process. Now I want to write the equilibrium constant for this reaction. The equilibrium constant is equal to ammonia, which is product, raised to the power of 2, or power of the coefficient, which is 2, and divided to hydrogen raised to its power of coefficient, which is 3, times nitrogen to its power of the coefficient, which is 1. So it easily can be solved by writing the equilibrium constant like that. What is the K value? K can be large or can be small. When it's large and it's more than 1, the reaction is product favor. It means that it goes to have more product, and in opposite, when the K value is less than 1 or small, the reaction is reactant favor. It means that goes to have more reactant and less product. What is equilibrium law or Le-Chatelier principle? Here I should give an examples of how we can make changes in the equilibrium. Le-Chatelier was a scientist, a French scientist, who has studied the equilibriums and said that when a stress is applied to a system at equilibrium, the equilibrium shifts to contract or minimize the effect of the change. In the other word, it helps us to understand how chemical reacts to just stay or maintain balance, such as adding more reactant or changing in temperature, changing in pressure, or adding catalyst. If we give more temperature, it depends on the reaction is endothermic or exothermic. Equilibrium can go to the right and or can go to the left. And when adding more pressure, the equilibrium goes to have more product. And in a less pressure or decreasing pressure, we will have more reactant. As an example, in Haber process, adding more nitrogen or adding more hydrogen gives more ammonia as a product. And also removing ammonia from the process lead to have more ammonia produced in the system. Adding catalyst increases the rate of both the forward and reverse reaction. And also equilibrium is achieved faster, but the equilibrium composition remains unaltered. Let's to have an exercise to understand it much easier. If 0.95 as an example moles of N2O4, which in this reaction is product, is added to a sealed 1 liter container and kept at 100 degree Celsius. Now calculate the equilibrium concentration of NO2 and N2O4. K is product, which is N2O4 concentration or molarity divided by NO2 raised 2. And now we have the K, which is 407. Let's go to Rice method. What is exactly Rice? In Rice method, R is reaction, I is initial concentration, C is changes in the concentration or changes in molarity, and E is the molarity at equilibrium time. If we put these expressions, as I explained now, in the K and makes it simple by multiply to 2x 2x to 2, we will get a quadratic formula. By solving this quadratic formula, you will get the x that is 0.2 or 0.25, which is negative. So we don't accept the negative one, and we know that the result is 0.2. Let's back to the Rice table. What is I in Rice table is initial concentration, the concentration at the beginning of the reaction. So 2NO2 at the beginning is 0. And we have N2O4, which is 0.95. But after a while, we will have 2x when the negative x or minus x removed from N2O4. And at equilibrium time, we have 2x, and the amount of NO4 and 2O4 should be 0.95 minus x. We have x 0.2, so we put it all in the right way. We have NO2 double 0.4 and N2O4 is 0.95 minus 0.25, which is 0.75. Let's summarizing. In this study, we know that the equilibrium is balanced, the same. And also we have studied about the chemical equilibriums and about the concentration, temperature, and pressure has affected on the reaction equilibrium. We also have learned how to calculate equilibrium constant, and we have learned about Rice methods to determine concentration, and also we know about the Lee-Shatler's principles. We will have more equation, more equilibrium constant to study, and more exercise. Please follow us, and in our next videos we will have more practices. Thank you for your attention. We will back soon.